Throughout 2017 and 2018, TVA conducted a remedial investigation of the East Ash Disposal Area, located at the Allen Fossil Plant. This investigation enabled TVA to better understand groundwater conditions and determine next steps. The Allen Fossil Plant is a retired coal-fired power plant located on the south shore of McKellar Lake, south of Memphis. The plant was constructed in 1959 by Memphis Light, Gas, and Water. In 1965, TVA leased the plant and began providing electricity to the city of Memphis. The plant included 3 coal-fired electric generating units. In November 2015, TVA began construction of its new combined cycle plant that runs on natural gas. This new plant began supplying power to the grid in April 2018 and replaced the coal-fired plant. In the past, coal burned at the Allen plant resulted in ash. The ash was mixed with water and piped to the East Ash Disposal Area, where it settled to the base of the East Ash Pond. When the pond water reached a certain level, it flowed to McKellar Lake in accordance with a permit granted by the Tennessee Department of Environment and Conservation, also known as TDEC. Features around Allen include McKellar Lake, the Industrial Park on President's Island, the U.S. Army Corps of Engineers, and the City of Memphis Biogas Facility, Sewage Sludge Unit, and T.E. Maxson Wastewater Treatment Plant. TVA routinely monitors the quality of groundwater around the East Ash Disposal Area. In 2017, elevated concentrations of arsenic were detected in the groundwater at 2 locations north and south of the pond. Fluoride and lead were also detected. In May 2017, TVA began delineating the groundwater areas and worked with TDEC to plan and implement a comprehensive remedial investigation. TVA finished the remedial investigation in November 2017 and published the report in March 2018. To gather additional information, TVA conducted a supplemental remedial investigation in late 2018 and published the updated remedial investigation report in March 2019. Allen is located within the valley of the Mississippi River. Beneath the plant, there are 2 groundwater aquifers, the alluvial aquifer and the Memphis aquifer, which are separated by a clay layer, the Upper Claiborne Confining Unit. The alluvial aquifer is a sandy layer approximately 100 to 250 feet thick. Groundwater from this aquifer is not used for drinking water. TVA uses wells installed in this aquifer to monitor groundwater quality. The Claiborne is a clay layer about 30 to 70 feet thick. This unit defines the bottom of the alluvial aquifer and limits vertical movement of the groundwater. The Claiborne is continuous beneath most of the East Ash Disposal Area, except in the southeast corner where it is offset or absent. This condition is discussed later in the presentation. Beneath the Claiborne is the Memphis aquifer, a deep sand layer used regionally for drinking water. Production wells for the Allen Combined Cycle Plant are located in the Memphis aquifer, but they are not in use. TVA is committed to not operating these wells until additional data supports safe use. The East Ash Disposal Area is located above the alluvial aquifer, and it is underlain by a layer of clay. It is surrounded by dikes and levees that are routinely inspected. The remedial investigation had 4 primary objectives: evaluate potential sources of groundwater impacts, delineate arsenic, fluoride, lead, and other potential constituents in groundwater, install wells and evaluate the alluvial aquifer, and evaluate connections between the alluvial and Memphis aquifers. To accomplish the first objective, TVA reviewed information on nearby sewer systems and industrial facilities and collected samples of ash pore water and ash from the East Ash Disposal Area. Ash pore water is the water trapped within the void space between the ash particles. Ash pore water is not the water that flows to McKellar Lake under permit. Field measurements of the ash pore water revealed unique geochemical conditions in the pond. The ash pore water exhibits high pH and low oxidation reduction potential, which is unlike other ponds. These conditions can increase the mobility and concentrations of metals like arsenic in ash pore water. Concentrations of arsenic in the Ashpore water ranged from 1.4 to 13,700 micrograms per liter, with an average of 1,350. Although the reaction is understood, the cause is unclear. Samples of ash were also collected and tested. Concentrations of arsenic ranged from 1.4 to 424 milligrams per kilogram, with an average of 85 milligrams per kilogram. To delineate arsenic and other constituents in groundwater on the north and south side of the pond, TVA drilled 22 borings during the 2017 remedial investigation and installed 20 shallow wells during the 2018 supplemental investigation. Approximately 80 groundwater samples were collected to identify the impacted groundwater areas. Samples were analyzed for over 30 constituents. Concentrations of arsenic were found above 10 micrograms per liter, which is the drinking water standard, also known as the maximum contaminant level, or MCL. The highest concentrations of arsenic were found in limited areas north and south of the pond. Fluoride and lead were found at concentrations above their MCLs in smaller areas within the boundaries of the arsenic areas. No additional constituents were found above MCLs. The highest concentrations of arsenic, fluoride, and lead were found within the upper 40 feet of the alluvial aquifer. To evaluate groundwater quality within the alluvial aquifer, TVA installed a total of 47 new shallow, intermediate, and deep monitoring wells for a total of 57 wells. 5 of these wells were completed during the 2018 supplemental investigation to confirm groundwater quality on the east side of the pond. Groundwater samples were collected 4 times, and over 150 samples were analyzed for over 30 constituents. No constituents were found at concentrations above MCLs in the deeper wells installed in the alluvial aquifer. On a regional scale, groundwater from the alluvial aquifer flows from south to north towards McKellar Lake, but McKellar Lake can rise and fall by more than 40 feet, affecting the groundwater flow direction in the alluvial aquifer beneath the East Ash disposal area. When the lake is high, groundwater flow can reverse and flow backwards to the south. Based on groundwater elevations observed during the remedial investigation, flow in the alluvial aquifer is predominantly horizontal, not vertical. To evaluate connections between the alluvial aquifer and the Memphis aquifer, 4 deep soil borings were drilled through the Upper Claiborne unit during the 2017 investigation, and 3 additional borings were drilled into the Claiborne during the 2018 supplemental investigation. These borings were used to evaluate the nature, depth, and thickness of the Claiborne unit. The borings confirmed the Claiborne is a low hydraulic conductivity clay layer about 30 to 70 feet thick beneath most of the East Ash disposal area, but in the southeast corner, a stratigraphic offset was identified and the Claiborne was absent on the south side of the pond. TVA has installed deep wells in these areas to monitor the alluvial aquifer and to confirm that arsenic remains in the shallow zone. In addition, groundwater samples were collected from the Memphis aquifer, and TVA enlisted the United States Geological Survey to perform a pumping test on the Memphis aquifer using TVA production wells. Groundwater samples from the production wells in the Memphis aquifer were collected 3 times by TVA and once by USGS. No constituents were detected above MCLs. The Memphis aquifer has not been affected by constituents in the groundwater detected at Allen. Pumping the production wells demonstrated groundwater drawdown in the alluvial aquifer, indicating a hydraulic connection with the Memphis aquifer. The greatest drawdown was observed in the southeast corner of the pond. During non-pumping conditions, groundwater gradients were observed to be predominantly horizontal, not vertical. The conclusions of the remedial investigation are as follows. The unique pond geochemistry causes arsenic to dissolve in ashpore water. Elevated concentrations of arsenic were found in ashpore water. The north and south groundwater areas with arsenic, fluoride, and lead have been delineated. The highest concentrations were detected in the upper 40 feet of the alluvial aquifer. 57 wells at shallow, intermediate, and deep depths have been installed at Allen. Groundwater flow is predominantly horizontal, not vertical, and the flow direction is affected by the level of McKellar Lake. Deep wells in the alluvial aquifer do not contain constituents at concentrations above MCLs. The clay-borne unit is a low hydraulic conductivity clay up to about 70 feet thick, which limits vertical groundwater movement between the alluvial and Memphis aquifers. A stratigraphic offset was identified in the southeast corner of the East Ash disposal area, and the clay-borne was absent on the south side of the pond. USGS observed a hydraulic connection between the aquifers during the pumping test. The Memphis aquifer has not been affected by constituents in shallow groundwater at Allen, and sample results met U.S. EPA drinking water standards. Now that the remedial investigation has been completed and objectives were met, TVA has moved forward with plans to continue groundwater monitoring and implement interim response actions. In December 2018, TVA prepared a groundwater monitoring plan that specifies quarterly groundwater sampling around the East Ash disposal area throughout 2019. Each year, the plan will be reviewed and modified as required to support the project needs. Interim response actions include controlling and treating impacted groundwater on the north and south sides of the pond. TVA is also removing free water and ash pore water from the East Ash disposal area through a dewatering process. From October through December 2018, the new wells installed by TVA in the north and south impacted groundwater areas were used to perform aquifer tests and confirm the horizontal and vertical extent of arsenic, lead, and fluoride. The results of the aquifer tests enabled TVA to initiate design of a system to pump groundwater to the surface and treat it as required by permit. Pumping the groundwater will control and treat the impacted groundwater areas, while TVA is planning and implementing closure of the pond. TVA is preparing for pond dewatering in 2019. This work will be completed in accordance with the dewatering plan approved by TDEC. The first step is to remove free water from the pond. The second step is to remove ash pore water, which is the water trapped within the void spaces between the ash particles. This will be accomplished by using well points or some other method for dewatering. Ash pore water will be pumped to the surface and treated. Dewatering and stormwater control will continue while TVA is evaluating closure options as required by NEPA, the National Environmental Policy Act. Closure by removal is TVA's preferred alternative. Under either closure option, TVA will eventually backfill and grade the area and evaluate groundwater quality beneath the former pond as required. In conclusion, TVA completed the remedial investigation at Allen and met the project objectives. The production wells at the combined cycle plant will not be operated until data supports safe use. TVA is now moving forward with response actions to speed the closure process and support future economic development. We are committed to protecting human health and the environment while doing the right thing for the people of Memphis.